Hello everyone, Eric Chappelle, Civil Community Evangelist for Autodesk, and I want to welcome you all today to our webcast, Workflows for 3D Visualizations and Sharing of Subsurface Geology. The star of our show today is Gary Morin from Keynetix, but before we get to Gary's presentation, I just wanted to talk about a few things regarding our webcast series and also our community. If you're new to this webcast series, this is something we do twice a month, typically first and third Wednesdays of the month. And the goal really is to bring, generally speaking, to bring together you folks, the ones who use our technology, closer with the folks who make the technology. And we've got a special guest presentation today. Gary is from a partner of ours, and we also have Dave Simeone on the call, who you all know. And Dave's going to talk a little bit about that partnership in a few minutes, but this is an extra special webcast because, again, we're hearing from one of the partners that develops the Geotechnical plugin for Civil 3D. Our next webcast will be coming up on Wednesday, September 20th, and during that webcast, we're going to talk a little bit about some new functionality that's coming out for Civil 3D. So you definitely want to catch that. It's probably the first place. In fact, I'm positive it's the first place you're going to learn about what's coming and what kind of feature additions there will be. And definitely sign up for that. Check it out. Information on how to register for that will be coming out in your email, as well as the community site and various other places. So keep an eye out for that after today's webcast. We'd like your feedback on topics that you'd like to see in the future. So if you have anything on your mind that you'd love to see, please enter it in the questions panel in your GoToWebinar interface. If you don't have anything right now and you think of something later on, no problem. Just pop it in there anytime you want. And we keep a running list of your suggestions, and that's what we use as a guide as we come up with new topics in the future. I want to also draw your attention to our new Autodesk Civil Engineering Community Center. This was just launched actually maybe a month ago, and this is a great resource for all kinds of stuff having to do with Civil 3D, InfraWorks, AVT, all the products that center around our civil and infrastructure design tools. And we feed in all kinds of different information into this central hub, information that's, news about the products, stuff from the user forums, stuff from the gallery, tips and tricks, webcasts, including this webcast series. Just the list goes on and on of good stuff. What's different about this site is that it's current. It's updated by the hour, by the minute. So it's a site you want to bookmark and check daily, sometimes hourly, because we're always posting more information up there from various sources, as you can see on the list there. And again, the URL is civil-community.autodesk.com. So definitely visit that, bookmark it, and check it every day. I don't believe we're going to be talking about any future stuff today, but just in case, we'll get this disclaimer out of the way. Anything we discuss that has to do with preview features or labs features or anything that we say we're working on, there's no guarantee that you'll see it until you actually see it in a supported version of the product, so don't make any purchasing decisions based on any future-looking statements. Questions, please ask lots of questions. We've got Dave Simeone on the call today to handle any Civil 3D related questions. We've got Roger Chandler on the line, also from Keynetix, who's going to be handling questions. So we've got folks standing by, and if there's a recurring theme or some especially interesting questions, Dave or Roger may interrupt Gary, and we can clear that stuff up out loud, and Gary can answer it for the whole audience here. So please don't hold back. Ask lots of questions. The more questions, the better. So with that, I'm eventually going to turn it over to Gary, but before that, Dave's going to say a few words about our partnership with Keynetix. So Gary, I'm going to make you presenter, and Dave, we're going to hear from you for a minute.
Great. Thanks, Eric. So yeah, I just wanted like about 2 minutes of time before passing it on to Gary. So the background on this, for those who are unfamiliar, is for, I don't know, for as long as we've had, Civil 3D, there's been a need to have the ability to model what happens under the ground. So boreholes and geotechnical surfaces and all of those things that go with it. And I think right from the beginning we realized this requires a different level of expertise than we currently had within our civil product team. So we looked at what's the best approach for us to give people a solution for this segment of the industry, and we started looking around, and we had a partner, Keynetix UK, and these guys are experts and have been experts at this for as long as we've had Civil 3D, frankly. And it became really quickly clear that the better approach versus us trying to internally build something was to come up with a partnership where we could leverage their expertise, leverage their existing technology to really fast track a great solution that ties tightly in with Civil 3D. So that was kind of what founded this whole effort. I mean, we decided let's find the best partner. We found them, and we came up with a solution that really ties tightly into Civil 3D at the geotechnical extension level. So they leverage our model directly, and they're able to manipulate surfaces and points and alignments and profiles and et cetera, in a very particular way. So they give, the relationship gives us that. And then what it also gives, I think, firms is the ability to extend that via the HoleBASE technology that Gary will talk about, which is something that Keynetix provides, right? So by working closely, we have something that ties in for the kind of the mass user base of Civil 3D, but then also ties tightly into the very, very specific kind of almost scientist type level that's needed when you're getting into deeper geotechnical analysis and modeling. So that's kind of the background on the relationship. Every year the guys at Keynetix come up with incremental functionality. This year is no different. We're able to really knock off some high value requirements that are needed for this space. So I mean, to me this has been, it's the poster child for how a partner relationship should be, where we've, by working closely, we're able to provide our Civil 3D subscribers with some really, really focused and high quality functionality that targets an area that we probably would not otherwise be able to deliver. So with that, hopefully, Gary, I kind of painted a picture. If you need anything while you're presenting, let me know. Otherwise, I'll be online answering questions.
No, that's great, Dave. Thanks for that great introduction. I can see already questions coming in at you. Nothing to do with geotechnics, nor roundabout alignments, Roger, so you'll be pleased you won't have to answer questions about roundabouts. But there is some technical questions coming in for Dave, I see. Anyway, back to the presentation. Workflows for 3D visualization showing subsurface geology. Let's just quickly go through what we mean from here, what we're going to cover. A little bit about Keynetix. It's going to be a very little bit now that Dave's gave us an introduction. We're then going to really look at and talk about the main part of this presentation, which is 3D fence diagrams. Why do you want to use them for visualization, what they are? And then we'll look at the options of actually creating them and modeling the information so we can create these great looking 3D fence diagrams. We're going to look at ways to do it in 2D, in 3D, how we can then bring them into InfraWorks. We're going to have a quick look at a third way. This is one of those futures disclaimer items, but this is what Keynetix is working on. And we'll obviously, as we go through this, answer any questions that you may have. So Keynetix, I think I'll go through this very, very quickly as Dave's done it all before, but primarily we develop software for geotechnical data management. So if you need to generate a borehole log, generate a cross-section, a fence diagram, that's what we develop our software for, and it works very closely with AutoCAD Civil. We work very closely with Autodesk, so we have lots of experience in this area. So without any more of that, let's just move straight on now. So to start off, I have a first poll question to ask you, and that is basically, Eric, if you can show the first poll question, please.
That is up as we speak.
Thank you very much. So if you could just let us know sort of what your job description is, or what your main role is, the work you do, be much appreciated. Thanks for the quick responses here. The answers are coming very rapidly today.
We're at about 75%, so I'm going to go ahead and close that, and I'll share the results for just a second.
Okay, excellent.
And I'm not sure if you're able to see those, Gary.
I can't, but I can see it in the little poll section separately.
Okay.
So quite an even spread across. So we've got 18% geotechnical engineers or geologists, 21% civil engineers, 26% CAD technicians, and 22% CAD stroke BIM managers, and 13% others. So thanks for doing that. Let's move on. That gives us a good idea of our audience. So let's start off then with the benefits of 3D fence diagrams. Well, I guess before we start saying what the benefits are, we really need to confirm what they are. So really, what we're calling a 3D fence diagram is a section, but in 3D, showing us the subsurface geology along these ribbons, as you can see here. As we move across here, you can see what do you actually use them for. Well, actually, I think this image almost says it for us. I don't need to put that many words. They're just a great way of visualizing and sharing subsurface information with the rest of the construction team, showing where problems may exist, where different geology runs through the different zones, but they go through the site. But there's probably less risk involved in sharing these. And what do I mean by risk? Well, if you share a nice shiny geology surface like we've got on screen here, it's nice and shiny, the computer generated, it must be right what's going on there. But in reality, that's not the way geotechnical professionals work. What they will do is they'll create a whole series of cross-sections across the site, and they will study these cross-sections looking at what geology is going on the 2D. So if you've got a point on the surface that is a long way away from where they studied, though we may have a very smooth, very accurate looking civil surface being generated, in reality, this point here may be nothing at all like what you're seeing here. So you may be able to measure it down to 0.0001 of an inch, but actually it could be meters, feet. That geology may not even be there. These cross-sections will be what the geotechnical professional is looking at and studying. So by sharing these cross-sections, they are more confident of reducing the risk, what's going on. Now, of course, if you're important, you need to know what's going on this particular point here, then you need to ask your geotech to create a cross-section and study what's going on in that particular place. So these are some of the benefits of sharing these cross-sections, as well as being visually a lot more user-friendly and easy to understand. Now, we're going to go in and start looking at the various options for modeling these fence diagrams. But before I do so, when you start receiving, I'm not sure at the moment how many people are using the geotechnical module, but when you start receiving geotechnical data or generating geotechnical data, there's quite often a lot of different terms used. So for instance, the geotechnical module, you can tell it to model using geology codes, legend codes, geology code 2. If you're working in the US, you may want to use soil classification codes, lithology, geology formation, lots of different terms. But actually, what are the actual data? What data do you need to actually model on? Well, actually, it splits into really two camps. Things that describe the lithology or the formations. These are basically describing the physical appearance of the material that you're looking at. So in the UK, we generally call these legend codes. In the US, it could be your unified soil classification system. And it's basically looking at really the breakdown, the percentage of how big the particles are. Is it sand? Is it gravel? What's the makeup and percentages of it? And it's really describing what the driller, the engineers on site have found as they dug the ground out. That information, though, is normally interpreted so that let's look at the actual engineering characteristics of that soil, what's common, and given a geology code, we call it in the UK. In the US, we found some organizations call it the engineering soil unit, and it's basically common types of characteristics or properties with a mass of soil combined together. Now the reason I'm saying this and emphasizing it is if we actually go and look at two typical log strips, the one on the left is based on physical appearance, in this case it's the soil classification, while the one on the right is based on the engineer's interpretation. If you see, as we go down this hole, we've got some clay. We then got clay with some silt in it. We're then back to clay again, then gravel, then some more gravel underneath that. But actually, in reality, for engineering purposes, we don't need all this complexity. And all this extra complexity is incredibly hard to model. So the engineer will look at that and they'll actually say, well, let's combine all this information into one big formation called clay. Let's call it gravel. Now the person who looks at this needs to have the engineering professional experience to look at this data and work out how does it combine. They'll be doing this also with lab results coming in, moisture contents, a whole host of other information while they interpret this data and look at it. But the reason I'm saying is that this is the information we ought to be modeled on, and that's the information you need to be getting or generating yourself to work with inside the geotechnical module. This then leads me to my next question, which if Eric can just show it, which is basically asking you who does your engineering unit interpretation. So basically, do you, when you receive the data, you or your team actually look at it and work out what the interpretation, how it's going to be used? Is that information just passed through to you? At the moment, and I've seen it quite often with some customers, they don't actually model at all on any of the geology. They just use the actual lithology codes in cross sections and that's it and nothing else. And of course, if you don't know, you're not unsure, then just put I don't know.
I'll leave it open for just a few more seconds. We've got about 70% voted. And let's go ahead and close it there. And I'll share the results so everyone can see them.
Okay, that's good. So looking at it, 35% of the team do it themselves, 31% have it supplied, and the others are either don't know or we don't model. Actually, I'm pleased to hear that. So that means, good 65, 2/3 of you are actually aware that you need to be working with geotechnical data and you're pulling that geotechnical information in to work with. That's good to know. Right, let's move on to the next one. Just double check here, Eric, is my audio coming over okay?
Yes, it is. Hearing you just fine on this on my end.
Okay, excellent. Let's crack on then. So where were we? So what we're going to do now is, thanks to that information, let's start looking at the techniques now to actually model these fence diagrams. So first one we're going to look at the moment is actually the full 3D modeling. So this is actually crafting, sculpting your surfaces to represent the geology. We're then going to go and look at, well, how can we create them by just doing simple 2D edits in the profile view. There is actually a third way, which we hopefully get time at the end to cover, or potentially a third way for the future we want to show you on there. So before we start doing that, let's start looking at the pros and cons of whether we want to model in full 3D or whether we're going to use just 2D edits. So if we look at the pros for the full 3D modeling, it gives the engineers, the geotechs who are pulling the data in, potentially a better understanding of the subsurface. They have to look at it all around in different ways and understanding how it is to actually manipulate their data. Once you have actually done the modeling, it then generates dynamic profile use. You make full use of the functionality in Civil, put a new alignment in, create a new profile. You've got the geology already modeled, it pulls it up, it makes it very quick. And of course, you've got a 3D model, then you can start generating volumes from it. You can use it for many other purposes. However, workflows are complex. I'm not sure whether actually the workflow itself is complex, but actually learning how to apply it can be quite complex. I guess it's a bit like learning to paint. Painting is quite easy, but actually learning how to paint and put the brush strokes in the right place takes a bit of skill and time to actually learn how to do it. And I guess it's the same thing with what you're going to be seeing here with doing the 3D modeling. You may need more data. If you had only a site with one borehole on, you can be as creative as you like in doing the modeling around that one borehole, but it actually isn't going to be any reflection, or it's going to be incredibly lucky if you actually get it to reflect what's going on there, because you only got one piece of information. So you may need more borehole, you may need more thorough data to actually do a more accurate model with it. And I've got down there, I was humming and ahhing where to add a bigger risk of misuse, but if you are going to create these surfaces to generate cross-sections, the fence diagrams with, showing the fence diagrams is good, but if you are going to also share the actual 3D surfaces because you created them with other people, you just need to really make sure how they're going to be using those 3D surfaces. Do they understand what it means to be a 3D surface of geology and how they should and shouldn't be used? So there could be more misuse with that type of data. 2D editing, generally it's faster to produce, it's easier workflows, generally speaking. Potentially there's less risk with it. The negatives are, one, it's not dynamic. If you realize you've done your profile, your alignment in the wrong place, you need to change it, you've got to redo the whole thing again. You can't go and generate 3D volumes from the information. If your data changes, you're going to have to go in and redraw your profiles, update your profiles all by hand. And if you need extra profile views, each one will have to be manually curated and edited to make it look the right way when you generate the fence diagram for it all. So yeah, there's pros and cons with two. In reality, I think generating full 3D models is the better approach, but it takes longer. 2D quite often is the quick answer to solve the problem. So let's go in and start looking at the steps involved in doing this 3D modeling. It's actually relatively straightforward. You draw a polylining plan where you think the extent of a particular geology type is. You convert it into a feature line and you make sure you then assign it an appropriate elevation so the Z values are correct. We then add that feature line as a break line to the appropriate surfaces, and if we need to, we can also add hide and show boundaries to show where that geology occurs across the site. It's pretty straightforward. In fact, this first stage, 2 stages, this is the way I tend to like doing it. If you are dab-hand at drawing 3D feature lines directly in the right place, use any technique you want to draw those feature lines. I tend to use this technique myself. So what do these feature lines actually represent? So here we've got a little example of some different strata, and we've got this material coming up over here, let's call it clay, and it stops here. So what we can do is draw a feature line where we think the extent of this particular clay is. So as it comes over. Across the whole site, you can see coming across is the green, and we think this is the extent. So we're drawing a feature line that is going to be in the right XY and in the right Z value, or Z value across the site. Now, generally speaking, they don't have to be at the extent of the geology. You could actually draw the feature line wherever you want to, if you want to sculpt and manipulate your geology surfaces into another position. And these are basically the techniques that we use everywhere. When you're doing this, it is important you understand the order of your strata. What's going on in the area I'm looking at. Is it sand, clay, gravel? Is it gravel, sand, clay? Is it some other material? Understanding your geology makeup, the order that you're looking at in your particular area, understanding this information is really important when you're doing this. And you'll see that as we go further through this presentation. There's a few do's and don'ts. So feature lines should not cross different geologies. So here, for instance, the red geology up here, which is our clay. Now, most of the people on this are seasoned Civil 3D users. So if we create one continuous feature line all the way down here, then add it as a break line to this surface, we know that this surface is going to suddenly extend all the way across here. Well, we don't want that to happen. So what we need to do is to draw individual feature lines that have a similar common geology above and below, once one of those geologies changes, you need to start create another feature line. Also, don't overhang it. Well, you can overhang it. If you do, though, you just need to make sure you move the Z value, the end of it, to the right Z value. Otherwise, you'll have suddenly like a great big cliff at the end of your site where your geology just disappears down to the middle of nowhere on it. So it's always best to snap and make sure you don't have tangles. But it's knowing these feature lines should only be drawn for when you've got common geologies above and below. As soon as one of those changes, start a new feature line. Now, in the project we're about to look at, the data we're about to look at, you'll see that we have some peat that we are going to start to model. And in one place, there's some boreholes with some peat in there. And what we're going to be coming back to these diagrams in a moment because it shows us the different geologies. So our peat is sat underneath our topsoil. Below our peat is our sand, and below our sand is the clay. And what we're going to do is, this is a simple cross section, we're going to be pinching together where our peat ends. Now the interesting thing is when we pinch it together here at the end, you've actually got 4 AutoCAD Civil 3D surfaces. You've got the base of the topsoil, the top of the peat, the base of the peat, and also the top of the sand, i.e. the material below, all being pinched together at that point. The same thing's happening over here. There's another part of the data we're going to look at where we actually have the peat coming in from one side of the site and it's being replaced by sand, as you can see here. Again, we have the same scenario. Our peat is sat underneath our topsoil and we're going to pinch together 4 different surfaces. In this particular case, there's also a feature line, a problem down here where our sand comes across and the extent of our sand is sat underneath our peat here. And again, you can see here, we're going to pinch together the base of the peat, the sand top, the sand base, and the clay top. So you'll see me coming back and using these diagrams in a moment. So let's move on now and actually jump into the world of AutoCAD Civil. So I've got some data in here, and let's just zoom in very quickly on these boreholes. In fact, what I want to do very quickly is just show you, if I connect through to our location manager here, can you see I'm displaying these boreholes at the moment by my geology code, i.e. the engineer's interpretation. If I flip that over to legend code, basically these are just a little bit more complex. The order, can you see around here how the order of things are slightly changing? The same material is repeating down the hole. You could try modeling it on this data, but it's going to be a magnitude more difficult because of the variation, and there's a lot more variation in there. So generally speaking, you want to show the geology codes. In your log strips, when you generate your profile views later on, you may well want to show your legends or your soil classifications in your log strips, but the actual modeling should be done on the interpreted engineer's data instead. So now we've done that, let's have a quick look and try to find out what's going on across our site. Now, you can see down this bottom end of my site, all these boreholes here have this white towards the top. This is my peat, and it comes along and it stops here. But then we have a whole series of red, where our sand starts. Sand again, here we've got sand and peat, or peat and sand I should say, peat and sand here. Now our peat's gone completely. And that's it. One other thing I've noticed here is, can you see we've got the green, which in this case is gravel on these 5 boreholes. In fact, they go all the way down the site, but they're not at the top end of the site here as well. So it's looking at the data, trying to understand what's going on across the site. And when I'm looking at this, this is where I should be using as much material as I possibly can do. Maps, background, photographs, a whole host of different information to give me as best picture of what could be going on here as I can possibly get. Another way to see this information is for us to go over to plan. If I go to the location manager, I can also tell it to show log strips on plan. In fact, let me just make these slightly bigger. Let's bring them up to 2 times the size. There we go. And again, you can see here, there's my boreholes with peat in. The peat disappears. Peat, we are going up here again. So you've got this information to give us a good idea of what's going on. So let's start bringing in the geology surfaces. In fact, I'm going to bring in the peat first of all, just to quickly show you. some of the stuff we're going to have to do, we just left it like this. Can you see it's joined all the dots together where we have peat all the way up to here, and our surface continues right through these boreholes where we don't have any peat. So that's what we're going to have to create and model and make it look right in a little bit. So again, let me just turn on all these other, let's create all these other surfaces. So it does that by just clicking. And with that done, I'm going to go through here now and tell it to create a geotechnical profile view. I'm just going to keep it, tell it to use my profile view style, tell it to just use stations, and we'll use all the default settings. We'll, for now, just display geology codes in my strips as well, and we'll put it over here. So if we now look at the automatically generated one, you can see now where we have the problems. There's we have the peat coming right the way across the site, then ending up here somewhere. This particular borehole here has no peat in it at all. You can see it passing straight the way through. It looks a bit of a mess and it needs correcting. So let's go in now and look at these techniques to do that. So what we're going to do is zoom in here and work out where we think the extents are for my peat. We'll start off with the peat first of all. Now, just to save a little bit of time, I've actually created the lines already. So what we've done here is I've just poured in here and I've drew some lines across where I think the extents of my peat is in the boreholes that we have in the middle. And also down here we've got two lines here. I'm just going to quickly flip back to my presentation. So those lines here, we're looking at it as a cross section. These are the lines that sort of, if you imagine going across our site, across here and here, that represents the extents of the peat. And if I go to the next slide, one line here is the extents of the peat going this way, and the other line is the extents of the sand coming the other way. Now, to save a little bit of time, the lines here have the same geology above and the same geology below. And we go here, you can see we have topsoil above and sand below. So what I'm going to do is when I go back into my drawing here, just to save a little bit of time, I can process that line, and that line, which are at the moment just 2D polylines. You can see them there floating in space. I'm going to convert them into feature lines. But when I convert them into the feature line, first of all, I'm going to say don't put them on any site. That's really useful for the geotechnical module. I'm going to say don't use sites. But I'm going to tell it to assign an elevation. We'll click on assign an elevation. And if you remember, our peat sits underneath my topsoil. So I'm going to say use the same elevation for my feature lines as the base of the topsoil surface. And now it's just moved it down. You can just see it disappear down here now on our 3D here. So with those done, I just pick those three again. And now I can start adding them as break lines to my surfaces. So I'm just going to quickly flip back to my diagram here again. Having this planned out in your head on what you're going to do really does help you. So this is my line, and it's going to be added, this feature line, to 4 surfaces. It's going to be added to the base of the material above, which is my topsoil base. My peat itself has a top surface and a base surface, so the peat top and peat base, and the material below it is sand. So we're going to also add it to the top of sand as well. And we do that by just clicking our lines and going to add to surface as break line. This is a little bit tedious, but all I'm going to do now is pick topsoil base and hit OK. We're just going to create it as the standard break line and hit OK there as well. And each time we do this, you'll just see our profile slowly manipulating. So now I'm going to come here and say, well, let's do it to my peat top. In fact, here you can see suddenly all my peat has modified the surface to match my feature lines here. Can't see too much yet in my profile, but you will do on the next one when I tell it. I'll also do the same to my peat base as well. And once we tell it to do it for my peat base, can you see now suddenly I've got my little lens of peat up here. I've got my other peat coming down here. So that's almost done. The only thing I've got to do still is pull my sand below up to the same point. So we just go in here and go the one below, which is sand top, and we pull that up as well. Okay, so that's the general principles of how you model this geology. I'm going to do it again, but this time for this one here. Now, this is where the sand comes along and ends up going below my peat here. So what I'm going to do here now is go through the same process again. Feature line, create an object from the object. I'm going to come through here and tell it, in this case, that line sits underneath my peat base. Okay, and we'll do that. We select it and we go through the same process again. So it's going to be on the peat base. And just to double check this, we'll go back in here again. So this is this line here. So it's sat underneath my peat base. We're working and manipulating the sand. So it's going to be the sand top and the sand base. And it's sat on my clay. So it's going to be the clay top as well. So we come through here and we'll go, I think I just did a peat base. It will tell me. I thought I had. So we'll go through. Oh, it's now going to be sand top. That's the surface. And you'll see again, as I click the next button, sand base, the profile suddenly update again. There we go. Just to finish it off, we have to do the surface below, which is our, in this case, our clay top. So we're almost there. You can see they've all been pulled in correctly. The problem we have got, and we'll zoom in here slightly closer, you can see this line in the red moving over, and probably you can see here as well. In fact, you can see it even better if I just go and turn some strata off. Let's just turn off all my other strata and just leave the peat on. Can you see how the peat is completely going across the whole site, even though it's not in these boreholes here? So what we're going to do is just clean this up now. Now the way in which I generally do this is by using boundaries. So again, here's one I've done before, at least some boundaries I've drawn. Now in this particular case, there's only 2 zones of it. So I don't necessarily have to do it the way I'm going to do it here. You could just delete these line edges here very quickly and job done. But if you ever update or change the data, they will suddenly appear again. So using boundaries is the better way of doing it. But this technique is going to look a little bit back to front. I'm going to show you. I'm going to select my surface. Okay, make sure nothing else is selected. Let's do that again. Select my surface. I'm going to go to add data. Hit boundary. But the technique I like to use, especially when I've got multiple lenses of a particular substance, is come in here and tell it to hide and pick an outer boundary. Pick this, sorry, this encasing boundary here and hide the whole of that geology. And then what I do is go add boundary, and this time do a show boundary. Then just pick the elements I actually want to be exposed and show. And there you see my 2 sections of peat being shown through. Now I actually have to repeat that process if we go back into the strata manager for the base strata for my peat as well. So we click on this little icon here. I can tell it to turn on my base, turn off my top of it all. So now we've got the base, and we just go through that same process again. We just pick it, go to add boundary, we'll tell it to be a hide boundary, hit OK, pick this boundary here. One more time, boundary, show boundary, and pick these 2. Okay, so we now got the top and base being pulled through, and hopefully you can see over here now how that's all been cleaned up. Nothing's showing here. So we really are ready now to work with this data. Now because we've been working on the whole of the model, the whole surface, what we can do is put some check-in cross-sections in really quickly. So if I go back to the Geotechnical Module now and tell it to create a new profile view for me, I'm just going to do a really simple one. Let's first of all just tell it to use profile view, tell it to use my stations only, create an alignment, and we'll just do a real simple one just going through my site over here. Hit next, geology code, and let's put that over here somewhere. Okay, so what we've seen here, can you see that's all joining up, all butt edging where we actually go, and the peat stops and the sand starts. And because we're using Civil and we've fully created a 3D model, if we move that to a new location, it all updates for us as well. So that's one of the big beauties of using full 3D modeling. Now with this all done, I can now go to my create fence diagram command, the whole reason for doing this in the first place. Come down here, select my two profile views I want to use on my fence diagram and go create. We'll just give it a second to go through creating it, and we should see now. I'll just make this view here, maximize it, zoom in a little bit closer there. But let me just come through here and just turn off a few bits so we can see it a little bit clearer. Turn off those log strips, shall we? Turn off the peak at the top. There we go. So now you can see, if we zoom in here, how we've got that sand dying away, the peak coming up over here across their site, being pulled through, etc., across their site. So that's really the first sort of the major technique for modeling the 3D geology. Just checking how we're doing time-wise. Right, what we're going to do now, let's go back in here and cracking on with this. Let's look at the 2D editing techniques now. So fundamentals of the 2D editing, or primarily we're going to have to work with the geotechnical profile view. And what we have to do is change the profiles, the surface profiles, away from being dynamic to static. And then once they are static, we can actually edit the layout of those profiles. Now this is quite an important thing you got to remember here, that once we change it from static, it's lost its relationship to that surface. So that surface is changes at all, you won't see those changes come through into your profiles anymore. So once you do this, it's sort of intelligence, the dynamicness has completely been severed from the two on it all. Now, even though this is a simpler process, when you've got 20, 30 profile lines going across your screen, it can still get confusing. So what I found is the best thing you can do is try to hide and make the drawing as simple. Hide things, grids from your hatches, remove hatching from your profile views, use custom profile styles to highlight what you're editing. You'll see this all now in the demo, but try to make it as simple and obvious what you're doing as you possibly can. When you've got loads and loads of lines, it's so easy to make mistakes. So we go back into this example here. So what we're going to concentrate in this particular case is finishing off this little modern tweak that we have up here. So what we're going to do here now is, let me just select this particular profile. I'm going to go down to edit profile styles, and the first thing I'm going to do is tell it to turn off my profile hatching so I can see my lines a little bit more clearer what we've got here. What we're going to do now is, now we're on there, I could just get working with it how it all is. But what I'm going to do first of all is just go in and quickly change the actual styles being shown. And you'll see what will happen as I do this. So I'm going to go across, select a style. I'm actually going to tell it to use this geology custom style that I've created for this webinar. Now this is not rocket science stuff here. What we do, so we click on that style, and all you've seen I've done is told it to put a little black square, just do a simple square where we have any vertical intersections across our profile. And what that means is, we come away and finish this off and hit OK, is we have lots of little dots appearing across my drawing. So basically what we're going to be doing at the moment is joining dot to dot as we put this information together. The next thing we need to do is change my profile into static so I can edit it. Now, picking them off the screen can be dangerous. What I recommend you do is go to your tool space, your palette space, your tool space, go down, find the actual alignment you're working with, go down to the profiles and select them from here so you know which ones you're clicking and which ones you're editing. So in this case, I'm working on my gravel. So I'm going to go down and go to my gravel top and make sure I pick it and click on properties there. And what we're going to do here is come across and see this update mode. It's dynamic. We're going to switch that to static. So it means it's now can be edited but of course it won't be updated from your surface anymore. And just to make it a little bit more obvious what I'm working on, I'm going to just use this particular style of I've created called Geology Edit, and all that does, as you'll see, it makes it bold so I can easily see the line. So that's the top of my gravel at the moment. So I'm just going to come in here, pick that line, tell it to, I want to edit it, and the next things are really straightforward. You've got this dialog box here. I can see it's gravel top. I've got selected. It's all highlighted. So I'm going to use this button here that is called Insert PVI. So we're just going to come across here and say, well, my gravel probably comes across to about this point here. Hit Escape, and that's it done for the top of my gravel. I'm going to repeat the same process now for the base of my gravel. So we come in here, we change it and make it static again, come across to Geology style, and we make that Geology Edit as well. Hit OK here, so you can see that line coming and stopping just down here. And we're just going to go through. Now notice here it's saying top there, so what I'm going to do is just click on it, and now it's switched it over and making sure we're working on base now. Okay, we're going to make sure we're in the right thing, and we're going to go and insert some more points. Let's do that one there. Let's move that a little bit away from there, like so. Okay. So we're almost done, but if you think about it, if I left it like that, we'll have a little void appear just around this area here. So we've just got to do one more to edit. Now again, I know this is limestone, so we could just do it this way. I think I'm just going to make sure I go through the right principles again. So we'll just do this one. This is the last one we're going to do. So again, static, Geology Edit, just so I can see, we'll make sure I've picked the right one. Yep, there we go. And again, let's just pick on it so that becomes active. And all I'm going to do now is just pull that so it fits. All I'm doing is joining these dots together as such. And I'm just going to insert a new point. This one here is insert a point, which is just there as well. So that is it done. So I'm hoping now, if I hit escape, just scroll out there a little bit. Let's go back to my properties again. Let's turn on my hatched areas again. So you can see now how that gravel all comes up and joins it correctly. And if I'm right in doing this, if we maximize my viewport, let's just zoom in here again. You won't see these changes straight away, but if I go to manage and tell it to rebuild my cross section, can you see it's using those edits in the profile view directly in there? But of course, if I move my alignment now and tell it to rebuild, it will go all over the place because those particular profile lines are not static. But there you've got that second technique of bringing in and editing the information. So I think that's the majority of what we're going to talk about. I want to go over now and just sort of cover some other areas in a moment. There's about a few different subjects I want to just quickly finish off with. So first of all, another poll question we want to quickly ask, which is what type of subsurface data and drawings do you produce at the moment? So none, just general site plans. These are multiple choice ones, so you can click as many, toggle as many as you want to here, not just one. So you're doing that. So cross sections or profile views. 13, 11, so some of you are already generating fence diagrams. That's good to see. So we'll just wait for you, just wait for people to wake up. I have a tendency of putting people asleep.
They're actually doing pretty well, Gary. The counts are going up quickly. I'll give it a few more seconds and then I'll close it down and share the results. All right, here we go.
Yeah, that's about it. So, okay, so 3/4 of you on the course are actually working on and working with geotechnical drawings, so that's really good to hear. 56% of you generate site plans, 56% of you generate 3D models, 30% of you are generating 3D models, so good on you, and 15% are already using fence diagrams. So I presume you guys are using the Geotechnical Module to do that, so that's good to know. So that's excellent information. Thank you for that, Eric, and everybody else for answering. Let's just quickly move on now. So what we're going to do now is start looking at the process of getting these fence diagrams in so we can bring it into InfraWorks. So this is going to be quite quick and easy actually, this section. We're going to look at perhaps exporting the data and bringing it into InfraWorks. I think just before I do that, I want to go back into this thing here. Now, in InfraWorks, and Eric may well correct me when I say this, but generally speaking, when you pull these 3D objects into InfraWorks, it can use the color, your layer color or the colors of your objects. But if there are materials associated to it, render materials, it will use those materials to color and render them inside InfraWorks. So you just need to be aware of how you add and remove materials to the data before you bring it into InfraWorks. Now, in the Geotechnical module, you can go to the Hatch Manager. And if we go and pick a particular material, so for every material type, every geology type we have, it will have an entry in here. So we go down, for instance, now look for peat, and we pick on peat, we will see that peat is this grey colour, but it also has a material, dirt, dark brown associated to it in this particular drawing. If I go and pick another geology, let's just go down and look at clay, hit filter on that, we see that we haven't got any material set to here for clay. Now, depending where you set the material, if you already got the objects created and they're already in your drawing, it doesn't always, when you change those values there, you don't always see those changes appear in here straight away. Now, what I'm going to do here, by the way, is I've got my shaded just to show me standard color. If I go into realistic mode, it will show me the actual rendered materials in here. Now, what you can do, if I want to quickly apply, let's say, a material for my clay, but I don't want it to be standard for all my projects, I just want it in this one particular drawing and nowhere else, there's an old AutoCAD command, if I get it right, called material attach, which will list you all of your civil surfaces. And if I scroll all the way down here to the base, we can see my Keynetix fence diagrams ones here, so fence peat, fence topsoil, we've got fence clay here, and if I scroll across to the right, you can see all our different materials. So if I wanted to apply, let's say I haven't got any clay in here, but let's just say for the sake of it, soil to my clay, I can just literally drag that over and drop it in here, and then that will apply that material to anything in my fences clay layer. All my fences will have that material on. I'm not going to do it for now, I'll just hit cancel on there. But it's just knowing that relationship or how you add materials to it so you can then see those materials inside of InfraWorks is important. But once you've done that, you've got all your fence diagrams done, you've checked it all, you've gone down here looking at the layout of the geology and you think you got it right. We can then use the export command here, and basically what it's going to do is just take my 3D boreholes, my fence diagrams and my plan items and put them into a new drawing. So I just literally come in here, type in the name of my drawing, export one or whatever, hit save, and it will save that drawing into a nice green cliff drawing that has all it has in it is that information and nothing else. Okay. So with that done, now please forgive me because my machine doesn't have enough memory in, so I can't actually run InfraWorks and AutoCAD Civil all at the same time. I've only got about 8 gigs in my machine at the moment, so I pre-recorded this one. Actually, it's not so much running those two, it's actually running GoToMeeting and GoToWebinar at the same time is the major problem. So here's a recording though I've done just to pull this information in. So we're just going to go pick my drawing. In fact, as I've done it before, it's a slightly different drawing name. Gets uploaded. Because we've drawn this drawing, we're working in the real units of where it's in space. This particular item, we just wait for it to get configured now. So what I've got to do now is in this project, just associate the right coordinate system for my import. So it's this one here. I've got in here ready to go. We've just got to allocate a feature type. So I'm just going to say it's city furniture. Doesn't really matter. Would be nice for us to get some geotechnical feature types in there at some stage. It's something we'll look at. And we'll just close and refresh. And now, when we zoom in here, you should see we've got our fence diagram being shown down here. Just doing this very, very quickly. In fact, you can also, like, I don't actually concentrate on the peat, but you can see that dark area, rendered material, the peat being shown up as we zoom in and around the site here now. So again, you can just see it's a great way of using this to share it with the rest of the construction team, use it to talk to the client where you're going to have problems, where you need to do different engineering because you found different materials down there, etc. So that's showing us how to import it in there. We're just about done now. There was just one thing I mentioned earlier on, a potential third method for editing. So at the moment we're seeing the full 3D modeling in 3D. We've seen how we can edit the 2D. What we wanted to do at Keynetix is see whether we could combine the two somehow. And so as Dave mentioned, we do a whole range of products for managing geotechnical data. These are HoleBASE products that are compatible with the Geotechnical Module. We also have a big brother to the Geotechnical Module called the HoleBASE extension for AutoCAD Civil 3D. So what I'm going to show you now is basically a pre-release version that we're working on. We hope to get released later this year of some functionality that we're working on that really is going to help generating fence diagrams and make it much, much quicker. So basically what we want to do is allow you to update the 3D model from editing the profile view. Okay, so so basically we're trying to combine the benefits of full 3D modeling, but with you working in 2D, or looking at in 2D, I should say. We believe it's easier workflows. We're trying to make the interface as intuitive, as easy as possible to work with. And let's say we're hoping to get this released later this year. This is a normal calendar, not the Autodesk calendar. This is the real world calendar that we're looking at here date-wise. So as this pre-release, I'm not going to risk trying to do it live to you. So let's go in here. So this is the HoleBASE SI beta. You can see it's the same project data we've just been looking at. And I'm going to go over to this area here, which is sort of create and edit section. So the idea is we want you to be able to create profile views, or in this case, we just call them sections, as quick as possible. So we just literally either pick on an existing alignment, job done, or you could just draw a new alignment and pop it in really quickly. So in comes that same data as you were looking at. I'm just going to concentrate on this end for now. So we now have this edit section command. If I click on that profile view, it makes this profile view editable for me. And you can see we come in and it color codes it, and you've got this little interface here now where we specify which type of geology we want to model. And you notice it's emphasizing, it's making it much more clearer what it is we want to look at and work with. So let's just go back to our topsoil here. Now, you need to keep your eye on both sides of the screen at the same time here. So as we drag this geology up here, if you look on the right-hand side over here, can you see the 3D surface is editing at the same time and changing at the same time? So by literally just dragging the dots around how you want it to look and feel, here we can actually update and modify the 3D model at the same time. So we're working in our 2D profile view, but updating the full 3D model as we go along. I hope you see that, you know, this is generally speaking a much easier workflow. It's easier to understand what's going on. We've still got a bit more work to go with it to finish it all off on it all, but it should be ready later on. So with there, for instance, I've just ended that editing session. If I go now and just create myself a quick fence diagram, just pick that profile again with the profile view we have there. In it comes. Let's go through to our Strata manager. I'm just going to turn off some of these different stratas so we can see the fence diagram a little bit better in there. What am I doing? Okay, I'm just showing the sand at the moment. So you can see where we raised the topsoil. You see it being shown in the fence diagram there. And we've got that little hole between below the fence, below the topsoil and the sand. So we just need to correct that now. So let's go back into the geotechnical, back into the HoleBASE beta, click on our edit section command again, pick the profile view we want to edit, and this time we're going to go through, in fact, we'll just first of all do a little bit of cleaning up with the peak down here. So you can see all I'm doing is just picking these lines, dragging them around to where I think they should go. So we'll just tidy this up a little bit more. There we go. Okay, so here I want to now flick over to our sand and just pull the sand up so it meets those top edges, like so. So really what you're doing is just concentrating and looking at what the geology, what you think that geology should look like now. So again, if we come back in here, let's rebuild our thing. You can see our fence diagram. You can actually see our surface there going up to that top edge. Let me just turn it off that sand as well so we can see a little bit clearer what we're looking at. And there we go with our fence diagram all being updated. Now the benefits of this, of course, is that the 3D surface is all updated, so it is still dynamic, so we can change that profile view, move things around, and we can still generate new profiles, new sections from it very quickly by working that way. So that's it, just about done for now. As always with these things, a couple of things just to add at the very end. First of all, we introduced this last year for 2017, but we've updated it now for 2018. There is a series of about 14 or 15 videos, tutorials on how to use the Geotechnical Module. If you're interested in them, they get sent to you in a number of emails over a few days. Please register. All you need to do is go to geotechnicalmoduletraining.keynetix.com. Okay, Geotechnical Module, no spaces, Geotechnical Module Training.keynetix.com. Just answer those, we'll register onto the site. As soon as you register, you'll start being sent training videos on how to use the Geotechnical Module. I think there's about, say, 14, 15 videos in there in total now. So that's that. And one last item is modeling geology can be quite difficult. Yeah, it's not so much the workflows, it's more comprehending how the items go together, where do you draw the lines. So to help you with this, we're also looking at bringing on and putting in place something what we call facilitated online learning. So it's a little bit like online learning material. The difference is that there's also what we call facilitated workshops. So these are instructor-led workshops where you combine on online material, looking at it, small groups of 6, 10 people at the most, working together, learning how to model. We're looking at the potential of doing these for just purely geotechnical modeling for the for geotechnical module users. So what I'm interested in, if you think that is something that you would be interested in, it will be like 2 or 3, 1.5 or 2 hour sessions, 2 or 3 of those over a period of days with lots of background training material as well to go with it all. If you're interested on it, I mean, if you could just answer this final poll question that we've got here. So we're basically saying there will be a cost involved in doing it. It's around $200. If you are interested, just say yes. If it is, but you won't have any budgets, click it. So just give us an idea of how interested people will be in doing this and whether we ought to develop this type of training for the future. Give us an idea if people are interested in it. Or just, as those coming in, Eric, I guess we'll open the mic. If there's any questions, anybody got any points they want to raise on here, we'll do our best to answer any questions you got while we finish this off. If anybody wants to contact me directly on anything they've seen today, if they are interested in this new version of the HoleBASE SI Civil extension with that third way of editing the 3D model, then drop me a line on gary.morin@keynetix.com. Otherwise, you can sign up for the training at geotechnicalmoduletraining.keynetix.com. That training, by the way, is completely free, so you can just sign up for it and access that. So without anything else, thank you so much for your time. I do hope you found this useful and you've learned something from it.
Gary, thanks a lot. That was a great presentation. I think we're pretty well caught up on questions, and we're just about out of time as well. So again, I appreciate everyone attending. Thanks to Gary for a great presentation. Roger's been in the background helping with questions. Thanks to Dave for giving us an intro in the beginning. And I just want to remind everyone that in 2 weeks we've got another webcast coming up on what's new in Civil 3D. So you definitely don't want to miss that, and be watching your email and the community site for information on how to register for that webcast. Thanks again, Gary, and we'll see you all hopefully in 2 weeks at our next webcast. Have a great day.
Thank you.